Nine, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
Mic is on.
Mic on. This one on.
Two.
Testing 1, 2. There we go. There we go. There we go.
Just talk and carry on with the session.
All right, here we go. Are we live?
Yes, we are.
We are live. We are live. Coming, guys. Coming, guys. Sorry about that technical difficulty. Welcome to SA. We back. We back. We back. We back. We back. Can you guys see me and hear me clearly? Hit us up in the comments, guys. Keep the vibe. We're going to be hitting. We cracked some lovely compound and double angle questions during the break, during this little comfort break that we had, coffee break. Are we all back in there? Masood, you in? Lovely. Is everybody in? We got a new link. Here we go. Here we go. Here we go.
It's not very good. It's okay. Okay, go.
Are we good? Yeah. Right, we're going. We're relax. There's no sleep here for the wicked, brah. There is no sleep. There we go. That's the new link. Let's go. Let's go. Let's go. Let's go. Let's go. That's the name they're gonna kill you. We love us a name. We back, baby. We back. There's it. This is the new link. Share this with your peeps. There we go. Here we go. Here we go. Let's give it a minute or so before everybody. Hassanin, you just lost the forgiveness for yesterday. Some of the comments coming in. Okay. We are live. We are live. We are live. We are live. Keep the comments coming. Keep the comments rolling. Let's see. I want to get everybody back in. I want to get everybody back in. Welcome back. Welcome back. Sound quality a bit bad. He's not forgiven. Salman. Can you guys hear me and see me clearly? Are we good to go, guys? Onliners, how we doing? Refreshed? You had a bathroom break?
Sorry.
We good? And we live. All right, let's go, let's go, let's go. So this is where we ended off with type number 2. Let's start with type number 3. Let's start with type 3. We are back. Right, type 3. Now type 3, they're going to give it to you like this. X squared minus 4x plus y squared plus 10y is equal to 2, for example. Right. Sometimes they'll mix this all up, but you need to put this into standard form. X squared, x, y squared, y equals a constant. This is what we call standard form. Question. Answer. What do we need to do? We need to find the coordinates of the center of the circle and the radius. Find the coordinates of the center of the circle and the radius. Now, whether they ask you to do this or not, you do it. The minute they give you an equation of a circle that looks like that, you find the equation of the center of the circle and the radius. Everything live for everybody. We're good to go. Right, let's go. I'm going to show you a shortcut. I know you guys have done this in school, am I right? And what did they show you? Your teacher showed you x squared minus 4x plus half times the coefficient of, you have complete the square, correct? Now come and show you how to complete the square in one line. I'm showing you a shortcut now, guys. I am showing you a shortcut. Pay attention. Now we know divided by 2 is 2 plus x squared, 2 squared is 4. What you did for x, you do for y. 10 divided by 2 is 5 plus 25. You square it on that side. And there we go. Here's your answer. X minus 2 all squared plus y plus 5 all squared. 4 plus 2 is 6 plus 25 is 31. Your center of your circle is 2 and minus 5. R squared is equal to 31. So R is equal to the square root of 31. And there we go. Divide by 2 plus that x value all squared. Divide by 2 plus the y value all squared. Sound good. Okay.
Yeah, but not so great. Okay. So the sound easy. Can you?
All right, let's go, let's go, let's go, let's go. Let's go. Are we good to go, guys? Talk to us, talk to us. Right. Let's do one more. Let's do another example of this. Let's do another example. So this was example number 1. We're now going to be doing example number 2. So let's go, example number 2. Now I'm going to mix it all up. So I'm going to say example number 2. So I'm going to tell you x squared plus y squared minus 6x plus 12y minus 1 equals 0. Right. They give you an equation of a circle. Equation of a circle. Find the coordinates of the center. Find the coordinates of the center of the circle and the radius.
Just so that the board file, the whiteboard is not on the same. So they sorted out the class.
Is it like minimized or is it?
On the thing. Yeah.
Sorry?
But get the whiteboard on the thing. Just for look here. They can't see it.
It's showing only the co-pilot. Guys, put up the board.
Wait. Just give me a minute. Here we go. Someone is playing around me. And now?
Yeah,
Okay, there we go. Thank you.
Thank you, thank you, thank you. Is that full screen? We got it full screen? Lovely. Answer. Onliners, how are we doing? How are we doing? Are we back? Are we back? Are we back? Are we back? How we learn, guys? Give us a talk to us, guys. Talk to us in the comments. Onliners, how are we doing? Can you hear me and see me clearly now? Are we back in the game?
On your camera, just get
Yeah.
Focus mo kitu camera.
Are we good?
Yeah. Please. Uncle. Working.
Right, let's go. So the first thing we need to do is put it into standard form. So rearrange. Firstly, you rearrange it. So that would be x squared minus 6x plus y squared plus 12y is equal to 1. Remember, take that on the other side. You want it in this form, x squared x, y squared y. Now we complete the square. So completing the square, divide by 2 plus x squared, divide by 2 plus y squared. So here we go. X squared, x, minus, minus. 6 divided by 2 is 3 squared, plus y plus 12 divided by 2 is 6 squared, is equal to 1 plus. What x are we talking about? That x value there. 3 squared is 9, plus which y value are we talking about? 6 squared is 36. So here's your answer coming up. X minus 3 squared plus y plus 6 squared is equal to 1 plus 9 is 10 plus 36 is 46. What's your coordinates of your center? Change the sign because your original got a minus in it. Plus 3 minus 6. R squared is equal to 46. So R is equal to the square root of 46. And we're done. We all okay? Everybody good? Lovely. You got it right? Using the shortcut? No? But now you know it? You promise? You're going to get it right in the exam? Don't stuff it up. PG show. Luckily, I can't say what I want to say. Think you know where I'm going with it. Onliners, how are we doing? How are we doing? How are we doing? Onliners, are we winning here? They can hear you, but they can't see my beautiful head. That's the name. That's the name. They can't see my beautiful head. Okay. Here we go. But you guys can hear me clearly. You want to donate for Vaseline? No problem, brah. Bring it in. Bring it on. Shine the ball. Shine that bowling ball. Let's go. You're winning. That's it, Gangat. Right. We now on to the last concept, finding the equation of the tangent. So put the heading, finding the equation of the tangent. Finding the equation of the tangent. Right, again, here goes. I give you a diagram. Take the diagram down. We give you the center. P is the center of the circle. -1, -5. And I give you a tangent there on the top. And that tangent, I call it point B. Let's give it a value. What do you guys want to call it? Let's call it 3 and 7. There's your point. Now, the question, find the equation of the tangent for 4 marks. Answer. Here's the template. Learn. Step number 1. Remember, to find the equation of a tangent, it's given by y equals mx plus c. We got a point. We don't have the gradient. But we can find the gradient. Why? From Euclidean, you know that your radius is 90 degrees to your... So firstly, step number 1, you find the m of your radius. M rad. You write it like this in your exam. M radius or MPB. Even if you want to, you can write MPB. Is y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. Minus minus 1 plus 1. 7 plus 5 is 12. 3 plus 1 is 4. So 12 divided by 4 is 3. Therefore, the m of your tangent is equal to, that's 3 over 1. So m of your tangent will become minus 1 over 3. Why? Because your radius is 90 degrees to your tangent. And the m of line 1 multiplied by the m of line 2 must equal to minus 1. Are we all okay there? You all understanding? So now we got the m of this line. The m of that line is minus 1 over 3. So therefore the equation of your tangent is going to be y minus y1 equals m into x minus x1. Now we have to use the point B because that's the point that lies on the graph. We have to use B3 and 7 for x and y. So y minus 7 is equal to m minus a third into x minus 3. Y minus 7, multiply that out, minus a third x plus 3 over 3 is 1. Here's your final answer, the equation of your tangent. Y equals minus a third x plus 1 plus 7 plus 8. And there we go, we are done. You got yourself 4 to 5 marks for that, for this template. Step number 1, m of radius. Step number 2, m of tangent. Step number 3, the equation of the line. Right here. Now the higher order question, the one where they ask you, another circle is given by. Will the two circles touch? Will they have two distinct points of intersection or no points of intersection? Have you guys done that concept in school? So let's say, hear me out. How's our onliners doing? Onliners, are we good? Are we good? Doing well. You back. People are screaming. I said, hey! Are we good, guys? Are we good? Talk to me. Onliners, you guys. Hmm? Of course. Yeah. Get me all the comments coming. Great. Okay, here we go. You guys got the same answers. Well done, well done, well done. Now watch this. Watch this. Here's your higher order question. This is the last of this. Then we're going into tricks. That's when the fun starts. Right. Watch here. Right. So they give you a circle x squared plus, let's say 6x. I don't know. Let's make up one. X squared plus 6x plus y squared minus 8y equals 2. Given that. Now they tell you another circle with the equation x minus 3 squared plus y minus 2 squared is equal to 10 is drawn. Will the two circles A have two distinct points of intersection B have no points of intersection or C be tangential Tangential mean will they be tangents to each other? Mean they will have equal roots. Show all calculations. It must be done by without sketching. Show by calculation. No sketch. Show by calculation. 5 marks. There we go. There we go. There we go. There we go. Now, to answer this type of a question, I want you to learn. You have to know this question. They love this question. You'll pick it up in almost every one of your past papers. Let's just see from here, from our cohort of learners. Were you shown this before? No. Good. So learn. Watch here. I'll show you something quite. Rules. Right. Have we got screen up? Screen up? Good. Let's go. Rules. If the sum of your radii is greater than your distance between your centers, they will have no points of intersection. If your sum of your radii is less than the distance between the centers, learn. You got to know this. Memorize this. Then they will have two distinct points of intersection. And if your sum of your radii is equal to the distance between your centers, then they will be tangential, or it means that they touch, the two circles just touch at one point, or they have equal roots. It's the same thing. So these are our three rules. You cannot answer the previous one if you did not know these rules. Please take these rules down and learn them. So now it makes our task for answering that 5-mark question very nice. Very nice, guys. Right, I'm from Durbanville, right. Okay, guys. Let's do math. Hey, math is mathy. China. Okay, guys. Let's go back. No, you're Mr. K. I knows you. Top K in the house, Baba. Let's crack math. Math is cracking. This is the code. This is the code to crack math. That's your code. You need a code. For every question, you need a code to crack. That's your code. So let's go. Go back to that question. So you got two circles. Now the first circle, watch here how it's done. There's a bit of calculation here. Because firstly we need to, that one is in good form. We got x minus 3 squared plus y minus 2 squared is equal to 10. So your sum of your radii, do it on your calculator, work it out as a decimal if you want. Let's go to our calculator. Let's plug it in. Root 10, root 10. How are we doing them, brah? Is everybody okay? Are they vibing with us?
Yeah, okay, but someone's switching the sound off. I don't know.
Sound, guys. Sound. What's happening there with the sound? Online sound.
Sounds back. It's okay.
Root 10 plus root 27, I get 8,35, I get 8,358, 8,36. That's the sum of my radii. My distance between centers. My distance between the centers. So now what's my first center? My first center is 3 and 2. My second center is -3 and 4. Now the distance between the centers is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So the distance between, calculating distance between centers. Hasanain, how are we doing there, brah? 3 squared is 9 plus 2 squared is 4, which is equal to square root 13, which is equal to, Hasanain, hit me up there, talk to me. 3,6 is 9. 9 squared is 81. Astaghfirullah. You see
You
what?
see what happened? 3 plus 3 is 6. You see,
This is
this is what happens when I start
stressing.
stressing.
Because
Because
my
my
online
onliners are not sharp.
and
I'm not smart.
Right, so
Right, so
let's
let's
go
go.
again. 3 plus 3 is 6. 6 squared is 36 plus 2 squared is 4, which is equal to square root 40, which is equal to square root 40, square root 46,32. So what can we say? The sum of radii is greater than the distance between centers. So the sum of radii is greater than. Sum of radii is how much? Sum of radii 8,36. 8,36 is greater than the distance between centers 6,32. So therefore, what is our conclusion? They will have no points of intersection. And now you won't lose that last 5 marks. Oh wait, what kind, Lani? Say wallah. You're making magic happen, improvising. You are bringing alien technology to the Western Cape. Pagamisa. Guys, are we back? Here we go. You sing Yo, the Nur ala Nur. Nur ala Nur. You sing it. You love the space, right? Come on. You have to love the space. Let's go. Guys, are we back? How's our comments coming in there? Come talk to us here, bruh. Guys, I'm not seeing your comments. You guys are not talking to me. What's happening?
I'm complaining about this.
Other screen. What's happening there? Right, here we go, here we go, here we go, here we go. Are we good, guys?
Here we go.
Yo, Asanin, they say you're not going to make it out alive here today. Bruh, they're sending an ICBM missile from Joburg for you, bruh. You better have your Iron Dome ready. Yeah. Sound is gone. It's off. Sound is off, guys. Now they can't hear me. We good? Are we good? Are we good? Are we good? Guys, talk to me. Talk to me. Talk to me. Guys, are we there? Are we there? They're saying no sound, no sound, no sound.
Okay, good. Yeah.
Are we good? Are we good? Are we good? Talk to me. How's the sound? Talk to us. No sound.
Can hear now.
No, no sound. Nothing coming in here.
No, that's the old comment.
Are those old comments? Can hear
Yeah.
now. No sound on their side. Umar Ahmad.
Oh my God.
Salman says we good. What's cutting? What's clapping, guys? It's back now. Right, let's go, let's go, let's go, let's go. Good. Sound back, choppy, but they can hear. Sound gone. Shahid Bule. Here goes. Right. All we had to do was calculate the sum of the radii. All we had to do was calculate the sum of the radii. There's the sum of the radii. And then we had to calculate the distance between the centers. And we got that. And all we did is we applied it here to the rule. The sum of your radii is greater than the distance between your centers. Your answer is no points of intersection. In fact, that's how you're going to answer. You're going to say in your final answer, this is how you're going to say it. You're not just going to leave it like that. You're now going to say in your final answer after all that calculation, you're now going to say your sum of your radii, therefore the sum of your radii is greater than the distance between the centers. Therefore, no points of intersection. And there we go. We are done. We are done with circle analytics. We are done with circle analytics. How are we doing there, guys? Onliners, please tell me you guys are okay. I know you love me. I love you too. They have beef with us, and they not with me. And then your head's on the Right, let's go. It's 12:30 now. It's 12:30. Let's break till 1:15. Let's break till 1:15. We come back. Hopefully in this time here, in the 35 minutes or 40 minutes, they'll sort out all the technical issues as well. Let's break. It is our break. We are scheduled for break. Oh yes, we are here. Let's go for break till 3:30 today. Salute. Assalamu alaikum. I'll see you guys at 1:15 p.m. Break till 1:15. Assalamu alaikum. There we go. What's clapping? So,
You guys are innocent.
Yeah, I can't leave you guys alone. You guys get some shit. Both of you, all of you.
Nothing. That's why we need you.
Now you don't need me. You guys can carry on and autopilot and sort yourself out.
Serious. Bruh, we had to eject seat, bruh. Mid-flight.
But they hate us and then
You, bruh.
That's not a problem.
that's not.
My coffee is on the block. It's not a problem. I'll take it off nicely.
Take it up the ass.
Mike, that's all.
What happened?
It's fine.
One, two, one, two, one, two, one, two, one, two, one, two, one, two. One, two. One, two, one, two, one, one, one. One, two, one, two, one, two. Two, 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 one. One, two. One, one, two. One, two. One, two. One, one, two. One, two. One, two. One, two. 1, 2. 1, 1, 2, 1, 2. 1.
see what's going on here. Testing 1, 2, testing 1, 2. Testing, testing 1, 2. Do we have camera there? Are we good, guys? Guys, drop the sound. Okay, here we go. No, this one is a bit too loud. Right, here we go. Is everybody back in? Let's get our onliners. How's our onliners doing? Let's get our comments coming in. There's it, our screen. Guys, just a quick thing before break. You know, my mind was in a million places, stressing about the technical issues. Just rewrite this. Distance between centers greater than sum of radii, no points of intersection. Distance between centers is less than the sum of the radii, two distinct. So please, correction. There we go. Here's your formulas. If the distance between, just drop it a little. Distance between centers greater than sum of radii, no points of intersection. Distance between centers less than the sum of radii, two distinct points. And distance between centers equal to the sum of your radii, they are tangential. We good? Here we go. Are we all right, guys? Onliners, how are we doing? We're starting now with trigonometry. We're starting with paper 2. There we go. Mr. Ballman is back in the house. Sound is good. Alhamdulillah. Let's go. Sound and picture good. We are live. Excellento. Thank you, guys. Lovely having you guys here with us for the entire weekend, and we're going to see you again before the prelims and before finals, inshallah. Say Amin. Right, let's go. We are starting now with trigonometry. Let's get started with trigs. Right, the formulas that you need to know for trigonometry. So let's just clear the frames here. I just want to clear the frames. Here we go. Let's get back, and we start. Put the heading trigonometry. We're doing compound and double angles, guys. We're doing the compound and double angles. So here goes. Trigs. What do you need to know in trigs? What do you need to know? So topic number 1, you need to know simplification. How to simplify. You need to know how to prove identities. You need to know how to give the general solution. We need to know how to do trig substitution with a diagram. Trig substitution with a diagram. Right. Then we need to know the area rule, the sine rule, and the cos rule. But most of you won't be writing on this. I think you'll only be writing up to trig substitution in your June exam. And there we go. Let's get started. Too much echo. Guys, techies. Links tip says too much echo. Drop that. Cancel that. Drop that audio. Let's see. Are we good? Let's get started. So please, these are the topics that you need to know, and I'm clearing the frame. So let's go. Now, sine of a compound angle. Sine A plus B is sine cos sine. AB, and the sine stays the same. So for sine, the sine stays the same. Take this rule down. You need to know this, guys. Sort this audio out, please. Right. Right, here goes. And then we got cos A plus B. Cos A plus B is going to be cos. Sine. I'm putting Hassanin under heavy pressure here. Cos A, there we go. And for cos, the sign changes. The sign changes. How are we doing there, guys? Lovely. So sine of a compound angle, sine, cos, sine, cos, sine, the sign stays the same. Cos of a compound angle, cos, sine. C for cos, C for change. For sine, the sign stays. For cos, the sign changes. The middle side. That is our compound angle, guys. That is our compound angle. Let's now go into the double angle. Here goes. Now we're going to do the double. I'm clearing the frame. I hope you took that one down. Let's go into the double angle. The double angle, we got sine 2a. Sine 2 times the angle is a, and you got cos 2a. Now remember, you need to remember these formulas. Sine 2a can only be broken up in one way, 2 sine a, cos a. But cos 2a, we all know, can be broken up in three ways. Cos squared a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a. Now I'll show you, once we start doing the application, how all this is done. How do we crack it? So I've got even a past paper here from Windsor High School. Right, so we've got some papers here that came in, and we're going to be cracking all of these as we go along. In fact, I'm even going to start off with the one that came out of last week's paper. In fact, the one that they wrote, the national paper that they wrote on Monday, the national June exam paper 2 that they wrote on Monday. Here we go. All good, guys? Onliners, are we doing good? Give us a thumbs up. Lovely. Let's start. So here goes. They tell you, if sine 40 equals P, if sine 40 degrees is equal to P, find each of the following in terms of P. Each of the following in terms of P. Right, so this is under the topic trig substitution. From that list that we had, trig substitution. So the first one that they give us is sine 220. This is from the past paper. This is June 2024. June 2024. Sine 220, cos squared 50, and number 3, cos of minus 80. Here we go, 2 marks, 3 marks. 2 marks, 3 marks, and then I'm going to throw you into another higher order question. How are we doing? Onliners, we can get started. You can get started with us, guys. You're on fire, Sian Temba. Well done. Let's go. The first thing that we do here is we draw our triangle. We draw our triangle. Our reference angle is 40 degrees. And we know that sine is opposite over hypotenuse from SOHCAHTOA. From SOHCAHTOA, sine is opposite over hypotenuse, so that's P over 1. And by virtue of Pythagoras, That is the square root of 1 minus p squared. So that's x. We can say 1 squared is equal to x squared plus p squared. 1 minus p squared is equal to x squared. X is equal to the square root, plus or minus the square root of 1 minus p squared. But it's on the positive side. It's on the positive side of your x-axis, so it's 1 minus p squared. Okay, the girls that gave me this one here, this document here, I took it from your desk. So I've got it here. Don't panic. Right, here goes. Guys, onliners, you can already get started with this. So Mavuko, he says he's back. Linkstep, Siatemba, Polani, Pamela, Blitz, Molele King. Well done. Easy. Let's go. Right, so let's go. Let's answer the question. Sine 220. Sine 220. What is the relationship between 220, a quadrant, and the reference angle? So it's going to be sine 180 plus 40. Now we know sine 180, the sine stays the same, so it will be sine 40. 180 plus is in my third quadrant. Sine in my third quadrant is negative. My answer, sine 40 equals P. They want minus sine 40. Your answer is minus. They want everything in terms of P. So your answer is minus P. How many of you got that one right? Onliners, give me a thumbs up if you got that one right. Here we go. Is the sound back? Is the sound gone? Sound's gone. Okay, just give me a second. Hassanain. Sound back. Are we back? What's going on there, guys? Nasir, we all right? Okay, here goes. Next one. Heads rolling. Right, let's go. Cos squared 50. Let's do the second one. Cos squared 50. Number 2. Cos squared 50. What is the relationship between 50, a quadrant, and the reference angle that they gave you? 50 degrees, a quadrant, and the reference. So this is equal to cos squared 90 minus 40. Now we know cos squared 90 would be sine squared 40. And sine squared 40, sine 40 equals P. So sine squared 40 is P squared. That's your final answer. Let's go, guys. Let's go. This is just a square root. This here, I just did Pythagoras to get that. Right, I'll try and make sure I don't write in that corner there. That's a square root of 1 minus P squared there in the corner. Perfect. You guys love my head. They are totally bamboozled by my head. Let me see how many of you are going to go cheese scope. You want to get an A in math? Shave your head, bruh. Cos of minus 80. Cos of minus 80. Cos of a negative angle, guys. Cos of a negative angle is positive cos 80. Remember, cos of a negative is positive. Sine of a negative is negative. tan of a negative is negative, but cos of a negative is positive. So this is cos 2 times 40. That's your double angle for cos. So this is going to equal to, in terms of sine, it's 1 minus 2 sine squared 40, which is equal to 1 minus 2 sine 40 is p, 1 minus 2p squared. There we go. 1 minus 2p squared. How many of you got that one right? They can't hear me. Sound is gone. Hasanain? Techies? Do you guys have sound? The sound. The sound is gone. Where's my guys? There we go, there we go, there we go, there we go, there we go. They can't hear. Sound is still fine. I think the chat may be delayed for you. Oh, okay. Sound is good. Sorry. I'm getting a different feed here. I'm getting a different feed. Sounds good. Because I'm a... Right, so here goes. Now let's see. I'm throwing you into the deep end. If cos 42, we said the best part for trigs. I told you, wait. If cos 42, that was the easy one, is equal to square root k. Find sine squared 69 in terms of k. There's this one here. And then I've got another one, another beautiful one for you guys immediately after this one. So let's go. This one is worth 4 marks. 4 to 5 marks. Let's go. So in our answer, let's go. I've got that. Here we go. So that's 42. So sine 42, cos 42 is k over 1, which is adjacent over hypotenuse. So root k over 1. Root k over 1. So therefore, this here is your y. 1 squared is equal to y squared plus root k squared. 1 minus k is equal to y squared. So y is equal to 1 minus k. So y is 1 minus k. There we go. We're done with that. So we completed our diagram. Thanks, Link Steps. I was reading old comments coming up on my feed. No, 1 squared is 1. Root k squared. Square and square root will cancel out. So that and that will cancel out. Plus k will come on the other side as minus k. So, oh yes, y squared is equal to, so y is equal to the square root of 1 minus k. Thank you. The square root of 1 minus k. Pressure here. Pressure. It's that biryani. Right. So now we got sine squared 69. So sine squared 69 is sine squared. Actually, it's cos squared. Sine squared 69. It's, watch here, watch, wait. Sine squared 69 is cos squared 90 minus 21. Am I right? Sine squared, not cos squared. Sine squared 90 minus 21. 90 minus 21 is 69. So we're going to put here sine squared. There we go. Thank you. Don't leave me alone here, brah. You're leaving me alone and putting me under pressure. So we got sine squared. 69 is 90 minus 21. Now we know sine squared 90 is cos squared 21. Right. So sine squared 69 is the same as cos squared 21. Now you got cos 42. Now cos 42 we know is equal to square root k. So cos 42 is cos 2 times 21 is equal to root k. Now we want it in terms of cos. So therefore this, in terms of that, is going to be 2 cos squared 21 minus 1 is equal to root k. Now all we have to do is make cos squared 21 the subject of the formula. So here we go, take the minus 1, take it over. So 2 cos squared 21 is equal to root k plus 1. Divide by 2, divide by 2, cos squared 21, which is sine squared 69. It's the same thing, is equal to root k plus 1 all over 2. And there we go, that's your final answer. There we go, that's your final answer. How are we doing there, guys? How's it going, guys? How's it going? Onliners, talk to me. Talk to me, onliners. Let's take the next one, yeah? Let's take the next one. Sound fine now? Thanks, Salman. Talk to us here. Keep us going. Keep us going. Keep us going. My head is in the way. Where's my head?
I removed it. I chopped it off.
Is that all comments?
Yeah. It was before I removed.
Please just sit here and don't move.
Okay.
Please. Right, let's go, let's go, let's go. Right. Prove the above identity. They ask you to prove that tan x into 1 minus cos squared x. Now, I haven't done this one. I don't even have the memo for it. But we're all going to be working through it together. Plus cos squared x is equal to sine x plus cos x. Ooh, this thing is long, guys. This thing is long. Just wait. Let's just rewrite this one, yeah? Right, so let's go. We need to prove that tan x into 1 minus cos squared x plus cos squared x is equal to sine x plus cos x. You can take this one down. Let's all do it together. Into 1 minus sine x cos x into 1 minus sine x cos x all over cos x. For 5 marks, prove. Ha, let's go. No memo, let's crack. Let's crack. Okay, so let's go on the left-hand side. I'm going to start on the left-hand side. I know tan x is sine x over cos x. 1 minus cos squared x is sine squared x from grade 11. Plus cos squared x. That is equal to, yeah, all right. So sine x times sine squared x is sine cubed x. So let's leave that as sine x times sine squared x. I'm just going to leave it for here for now. Over cos x times 1 is cos x plus cos squared x over 1. You see the right-hand side has got a cos x at the bottom. So I want to try and keep a cos x at the bottom here. So what I'm going to do now is I'm going to put a line there. Cos x, let's go there. Cos x into cos x once, 1 times sine x. So we're doing the LCD, lowest common denominator. So I'm left with sine x times sine squared x plus 1 into cos x times cos squared x, cos x times cos squared x, cos x times cos squared x. Okay, all over cos x. So now they've got this here on the right-hand side. We got sine cubed x plus cos cubed x over cos x. We got sine cubed plus, I see something here. I don't know. I see sine cubed x plus cos cubed x over cos x. Okay, let's go. I see something here before I even go to my right-hand side. How about if these are two perfect cubes in algebra? I don't know. Let's just try. So the cube root plus the cube root. So what am I left with? Sin x plus cos x. I'm factorizing it. I think I'm going to need more space. So I'm not going to move over to the side. I'm going to move over onto a new page. So we got sine cube x plus cos cubed x over cos x. We got, let's see what we have. We've got sine cubed x plus cos cubed x over cos x. How's our comments coming there? Talk to me. Khalid, you're not talking to me here, bruh. If I had to factorize that over cos x, that would be sine x plus cos x. I am factorizing this. It's a sum of two cubes. We square the first term, sine squared x. We square the second term, cos squared x. Cos squared x plus cos squared x. And then we multiply the two and change the sign. So that would be minus sine x cos x. Now, I've got an identity in here. Sine squared plus cos squared is 1. I think we're getting the answer here, bruh. Whew, I can relax now. Under pressure with no memo. Sine squared plus cos squared is 1 minus sine x cos x. Does it look like the right-hand side all over cos x? Is that the right-hand side, guys? 1 minus, like a boss. There we go. Kwai Yong Kwai. Let's go back. So those of you who didn't take that one down, now you can take this one. Yebo. No, where? No. Where? Yeah. Let's go there. Let's go there. Where there? Multiply the 2. No, you're not multiplying the 2 and timesing it by 2. You multiply the 2 and change the sign. When you watch here. If I told you x cubed plus y cubed, what would that be? That would be x plus y. Square the first term, x squared. Square the second term, y squared. Multiply the two, xy. Change the sign, minus xy. This is not x plus y squared. X plus y squared is x squared plus 2xy plus y squared. They are different. You are factorizing a cube. Here you're factorizing, so you multiply the 2 and change the sign. To get the middle term, you multiply the 2 terms and you change the sign. Are you with me? You see it? You see the difference? Good. So there we go. So those of you who are taking this one down, take this one's corrections down. Here we go. So we're getting called GOAT, greatest of all time. Hey, Kwai Yong. Yes. As I go on to the next slide. Right, take that one down. Okay. Prove that. Let's go into the next one. Let's go into the next one. Okay, for those of you who have taken that one down, let's go into the next one. Prove. Here goes. Prove that sine 3x is equal to 3 sine x minus 4 sine cubed x for 5 marks. Take that one down. Take that one down. While you're doing that, I'm going to work out another one for you. Totally different one. I'll give you guys a couple of minutes to crack this one. Then we're going on to general solution. Let's go, let's go, let's go. Let's go, let's go, let's go. Let's see how you guys cracking this one. Start on the left-hand side. Start on the left-hand side. Break that up into sine x plus 2x. Break it up into compound. If you see that sine 3x, break it up into compound. So that's your compound angle. So let me just help you along. Sine cos, cos sine. X 2x, x 2x. The sign stays the same. Now we need to break all this. That's your compound angle. Now we need to break up all of this in terms. My right-hand side is only in terms of sine. So break up all of that only in terms, break up that in terms of sine, break up that in terms of sine. Are you guys following there? Are we all okay there at the back? We okay? Right. So we got sine x. There we go. We got sine x. Cos 2x in terms of sine is 1 minus 2 sine squared x. Double angle for cos. Plus cos x times sine 2x is 2 sine x cos x. Khalid, how are we doing there, bro?
They're loving each other, yeah. They're in love with Zubair. I don't know.
Yeah. So here we go. Sine x times 1 is sine x. Minus 2 sine times sine is sine cubed x. Plus, that's one term, so that's 2 sine x. Cos times cos is cos squared x. So we got a sine, we got a sine, we got a sine. Give us a sine. Cos squared x. Let's get a sine from cos squared. So now we got sine x minus 2 sine cubed x plus 2 sine x. Cos squared is 1 minus sine squared x. Let's multiply this out. Sine x minus 2 sine cubed x plus 2 sine x times 1 is 2 sine x minus 2 sine cubed x. Now sine x plus 2 sine x, 3 sine x, minus 2 sine cubed minus another 2 sine cubed, minus 4 sine cubed x, which is equal to your right-hand side. Done. Done. Few tricks of the trade. So when you see 3 times an angle, you break it up into compound and then break it up into everything, whatever the right-hand side wants. It wants it in terms of sine, break out your compound angle in terms of sine. Okay. Those of you who are done with that, how about 4 times an angle? How about 4 times an angle? Prove that cos 4x is equal to 1 minus 8 sine squared x plus 8 sine to the power 4x for 5 marks. This is not sine 4x. This is sine to the power 4x. Let's go. Those of you who are done with that, start with this one. There's a couple of problems I want to throw you into the deep end with. Right. Take this one down. Let's get working. Let's get cracking. Give it a go, guys. Work on it. Work. And do not break it up into 2x plus 2x. I hope you guys haven't done that. I see many of you are smiling. You broke up 4x into 2x plus 2x. No. What did you break it up into? Good. Good. Work it out. Work it out. Work it out. Yo, I was working out another problem. I just the problem that came out in Monday's paper. So a bit of a, but we cracked it. Don't worry. So let's get back to this one. It's a Kwai one. It's a Kwai one. Good stuff coming up, guys. Good stuff coming up. The one that came out, I'm going to do that one that came up in Monday's paper after this. Right. So we're going to start on the left-hand side, cos 4x. And that we're going to break it up into cos 2 times 2x. Your reference angle now is 2x. That's your cos double angle. Your cos double angle. Now we need this in terms of sine. So that's 1 minus 2 sine squared of your angle. What's your angle? 2x. You got it. It worked out. You're not yet done. Okay. Are you stuck here? Are you stuck here? Right. Many learners get stuck at this point. Come, I show you what you do here. If I teach you this little concept, you sort it. Check this out. All you do is you say 1 minus 2. You are squaring the angle. You're not squaring the trig function. So it's sine 2x squared, like that. Now break that up. 1 minus 2. Sine 2x is 2 sine x cos x all squared. That is 1 minus 2. Now comes the algebra. 2 squared is 4. Sine squared x cos squared x. You agree with me? Are you smiling? Yeah. For which one? For, it's in terms of cos. It's cos 4x. So 4x is 2 times 2x. And your right-hand side is only in terms of sine. Look at it. You got sine, sine. So I had to use the double angle in terms of sine. I couldn't use the one in terms of cos. I had to use the one in terms of. That's 1 minus 2 times 4 is 8 sine squared x cos squared x. So watch here to answer your question. Now we got cos squared. We need to get rid of cos squared. So 1 minus 8 sine squared x. And cos squared is 1 minus sine squared. Now multiply out. 1 minus 8 sine squared x times 1 minus 8 sine squared x. Negative times negative is a positive 8. Sine squared times sine squared is sine to the power 4x, which is equal to your right-hand side. Correct. Why? After I sorted that out, you got everything worked out. That's the challenge. That's the trick. Whenever an angle is squared, a double angle, put the double angle, pull the square outside, then break up and then square it. That's how you crack it. It's a landmine. It's like when you're walking through a minefield, you know, kaboom. That's what I'm here to do. Show you how to avoid the traps or how to dismantle the bombs. Because you're walking into a minefield. Mission failed. You used compound and got it faster. I don't think so. Links, you used compound and you got it faster. I don't think so. Right, here goes. The next one. Now the next one I never saw before in my life. That's why I was thinking now, should I crack it? That's why while you guys were doing that one, I cracked it here on the side quickly, but I said, why? It's the one that came out in Monday's paper, and I don't have a memo for it. But I know my answer is right. Let's go. The next one. Check this one out. They say, watch this. It's the first time I ever seen something like this before. The next one. Check here, check here, check here. They tell you if, take this one down, sine 150 plus cos squared x minus 1 over 2. You given that. Actually, not that. Given. So put the heading, just put there, given. Right. Simplify the expression to a single trig ratio in terms of cos 2x. Simplify in terms of cos 2x. And they gave you 6 marks for that. This was now Monday's paper, June 2024. You don't get a fresher question than this. It came out in the week. I haven't seen it ever. I've never seen this before. But if we know our rules, we will crack this. Give it a go. Let's see all your smarty pants. Some of you will get it. Some of you will sweat. Let's check. Let's check. Let's get it cracked. Let's crack the code. Go for it. Reduce. Work. Right. Come. Let's go. Let's see. I see people working here. This entire cohort of learners here in Cape Town also, they're working. The brains are... Reduce that. You got to change that first. What is sine 150? Sine 150 is sine 180 minus 30 plus cos squared x minus 1 all over 2. So what is this? Sine 180 minus 30 is sine 30 plus cos squared x minus 1 all over 2. Sine 30 is a half, special angle, plus cos squared x minus 1 all over 2. So now, I'm splitting it up. Watch here, watch here, watch here. I'm splitting that, splitting that, splitting that. So I got a half over 2 plus cos squared x over 2 minus a half. A half divided by 2 is a quarter plus cos squared x over 2 minus a half. I'm going to move over to the side. What is a quarter minus a half? What is a quarter minus a half? Is minus a quarter plus cos squared x over 2. That minus that is that. Now I'm going to do LCD. My common denominator is 4. 4 into 4 once. 1 times minus 1 is minus 1 plus 2 into 4 2 times. 2 times that is 2 cos squared x. And they want it in terms of cos 2x. So I've got 2 cos squared x minus 1 over 4. 2 cos squared x minus 1 is cos 2x. That is cos 2x over 4. And there's your final answer. Or you can say a quarter cos 2x. Whether you put it like that or whether you put it like that, both of them are correct. You will get 6 marks for that. Like I said, that was the paper that came out. This was one of the questions that came out in Tuesday's paper. Now they want, and they say, now remember, this one question was 11 marks, so this was 6 marks. The next 5 marks was to give the general solution. Hence, find the general solution. Watch here. Here's your next question. Now find for 5 marks. Hence, find the general solution of sine 150 degrees plus cos squared x minus 1 all over 2 is equal to 1 over 25 for 5 marks. Right, let's do this. So 6 and 5, 11 marks on these 2 questions. You cannot afford to get them wrong. How's the comments coming in? Everybody all right? How's our guys?
I tried. So too easy.
Too easy. Okay. Owens are on fire. Owens are on fire. I want to see how many of you get the next one right after this. The ones who are saying too easy. It's coming, Baba. It's coming. So we found that that was cos 2x over 4. Therefore, cos 2x over 4 or a quarter cos 2x is equal to 1 over 25 times 4 times 4 cos 2x is equal to 4 over 25. 2x is equal to plus minus. Right. Shift cos. Go to your calculator. Go to your calculator. We are now doing general solution. Go to your calculator. Now we say shift cos 4 over 25. So shift cos 4 over 25. 80,79 plus minus 80,79, 80,8 plus k times 360, where k is an element of integers. So x is equal to, let's divide that by 2. 40,4 plus minus 40,4 plus k times 360 divided by 2, 180, where k is an element of integers. And there we go. We got 6 and 5. We have got 11 marks. We got 11 marks. How are we doing on time? Right, here we go. I hope you guys enjoyed this. I'm going to throw you in again now with another one. Here we go. I want to show you two more. If sine 36 cos 12 equals P and cos 36 sine 12 equals Q, find in terms of P and Q. Question number 1. Sine 48, sine 24, cos 24. Mark allocations. 2 marks, 2 marks, 4 marks. This question is out of 8. Here goes. Let's go, let's go, let's go. That's your one question. Just trying to think of the other one. Go for it, go for it, go for it. Go for it. I'm trying to figure out, I'm working out something in my head for something else. Cos 2x minus sine 2x. Yeah. Come, guys. Let's go. Right, let's start with sine 48. I'm answering question number 1, sine 48. Sine 48 is equal to sine 36 plus 12. 36 plus 12. And that's your compound angle. Sine cos, cos sine, 36 12 plus 36 12. We know sine 36 cos 12 is P plus cos 36 sine 12 is Q. Your answer is P plus Q for the first one. That's why it's only 2 marks. Easy stuff. How's our comments coming in there, guys? I got a quiet one for you. The next one.
Got number 1 and 2 right.
Yeah. You got number 1 and 2. Who's that? Innocent Banda. The question is get number 3, Baba. Number 3 is the one. That's title fight. That's Mike Tyson. Sipamandla. Number 3. Yeah, number 1 and 2 is easy. I'm telling you it's easy. The last one, you got to use your brains. No, 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 no. Let's go. You coming back, ne? Kom terug, ne? Number 2. Sine 24 is easy. Sine 24 is equal to sine 36, the two reference angles, 36 minus 12. That is equal to sine cos, cos sine. 36, 12, 36, 12. And the sign stays. That is P minus Q. That's your answer. Do the last one. Thank you, boss.
Tada.
As long as I know my sound is right and my picture is right and my audience are sharp, my learners are sharp, I'm sharp. Here goes the last one. The last one. Right, so we got P plus Q, P minus Q. Let's just put this in red. The first one was P plus Q. Second one was P minus Q. That's the one we want. We want cos 24. Now watch how we do this. Cos 24. We also know that cos squared 24 from grade 11. We know that cos squared 24 is 1 minus sine squared 24. This is your grade 11 identity. So therefore, cos squared 24 is equal to 1 minus sine 24. We found it in the previous one, P minus Q squared. So therefore, cos 24, what they want, is equal to the square root of 1 minus P minus Q squared. And there we go, we are done. So I use the grade 11 identity of sine squared plus cos squared equal 1. You square it. Sorry? I know, but I can square it. I just found the square root. You can square something in the start and find the square root at the end. No, you're not understanding. No, you're not understanding. All right. All right. Let's go again. Let's go again. So some people are saying, no, they're not understanding this one. Watch this. Watch this. Boom, shark. You know David Morales?
Yeah.
Yeah. This the one is murder. Right, you need cos 24. Now if I square this, what is cos squared 24? Cos squared 24 is 1 minus sine squared 24 according to your grade 11 identity. Yes or no? So, cos squared 24 is equal to 1 minus sine 24 is P minus Q. You found that out in the previous one, squared. Now, I don't want cos squared. I want cos 24. Find the square root, find the square root. Therefore, cos 24 is equal to the square root of 1 minus P minus Q squared. Yes or no? You want me to show you another way? Yeah, that's your answer, cos 24. Are you with me? You want a different way? Okay, this was using by using the grade 11 identity, right? Okay, so here goes. You want a different way? I give you a different way. I'll give you method 2, an alternate method if you don't want to use the grade 11 identity. Watch here. Watch here. We know from the previous, I'm answering question number 3. We know that sine 24 is equal to P minus Q over 1. Yes or no? So all I do that, I do that, I do that. I put 24 there. That's opposite over hypotenuse. That's P minus Q over 1. I need X. I need the last side. Yes or no? By Pythagoras. So 1 squared is equal to X squared plus P minus Q squared. 1 minus P minus Q squared is equal to X squared. X is equal to the square root of 1 minus P minus Q squared. So this is the square root of 1 minus P minus Q squared. Therefore, cos 24 is equal to adjacent over hypotenuse. Cos 24 is equal to that over that, square root of 1 minus P minus Q squared over 1, which is equal to the same answer, the square root of 1 minus P minus Q squared. Clar. Quay. 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 Aikido, Baba. Aikido. Long shot. Long shot. This is body shots. Here we go, here we go, here we go. So whether you want to draw a triangle or you want to use your grade 11 identity, you are right. Okay, there's a last one I want to show you. A last trick. Remember, I need to make you varam. You're walking into the ring. You are about to fight. You are Jake. Okay, you're not Jake Paul. I don't want to call you Jake Paul. You're going to fight Tyson. You're going to fight somebody. You're going to fight a seasoned boxer, a heavyweight. You need to know where his weak points are. Otherwise, he's going to bust your face. Guys, I want to see you guys looking as pretty after the paper as you went in before the paper. I looked at that other meme on Instagram the other day, and there was this chick, man. Her whole face is all busted and everything, and they're interviewing her, ask her, how was the fight? She said, fight, it went well. Bruh, she was busted. She won, but she was busted. She didn't have a nose. She didn't have eyes. She didn't have any. Guys, don't look like that when you come out of math. You need to look as beautiful as you are after the match than before the match. You need to crack math. Crack the code. Otherwise, you will fail. Nicely. Check this. So here's another trap. Here's another trap. Watch this. Let's set the trap for you. Let's set the trap. Clear the frame. What's going on here, bruh? No, 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 no. No, no. Don't be naughty. Right, let's go. If sine 22 is equal to m, find sine 11 in terms of m for 6 marks. Don't do it. It's a trap. It's a trap. It's a trap. Mr. K, don't do it. It's a trap. Let's see who's sharp. You sharp, you'll get it. This is heavyweight. This is heavyweight. How's our onliners doing? Are they still alive, bruh? Or have they K'd out? Have they tapped out already? Who are they, Khabib or Conor? Have they tapped out? Oh, they... Let's see, let's see, let's see, let's see. Guys, it's a trap. Easy. Let's see how you do it. Yeah, if you're a K-Way student and you attended our workshops before, you'd be able to crack this one. But this one, it's a trap. Right, so let me show you what to do. Listen now. Mamela, open up your ears. Listen. Some of you are going to be screaming. Right, the first thing we do is we draw a triangle. So we know that this is 22 degrees and this is m over 1. And we know that's the square root of 1 minus m squared. Now look where I start. I'm starting with cos 22. Shh. You'll see the benefit of this. Don't ask questions for now. That's your start. Listen. Just pay attention. You'll see the art. You'll see the beauty in this just now, in the next step. What do we know about cos 22? Cos 22 is the square root of 1 minus m squared. Yes or no? Over 1. Yes or no? Now pay attention. Now I break this up into my double angle. Cos 2 times 11. Double angle. Square root of 1 minus m squared. Now that I break up into sine. So that becomes 1 minus 2 sine squared 11. I think you know where I'm going with this. Is equal to the square root of 1 minus m squared. You know where I'm going with this. Now all we do is we make sine 11. Do not ask me why do I start with cos 22. Because I want to break it up into cos double angle and from there get my sine. So I'm going giga giga. Via. So now take the 1 on the other side. So minus 2 sine squared 11 is equal to the square root of 1 minus m squared minus 1. Divide by minus 2. Divide by minus 2. Sine squared 11. Sine squared 11. Negative divided by negative is a positive. So it's 1 minus square root 1 minus m squared over 2. And sine 11. We want the final answer here. Sine 11. Therefore, sine 11 is equal to sine 11. Find the square root. Find the square root. The square root of 1 minus the square root of 1 minus m squared over 2. There's your 6 marks. And we drop the bull. We just dropped the bull.
So,
Yes. Okay. You can't. You're going to get stuck. You're going to say sine 22 is equal to m over 1. Then you're going to say sine 2 times 11. Then you're going to get 2 sine 11 cos 11. Then you got a sine 11. You stuck. What happens to cos 11? That's why we use cos 22 instead of sine 22. You would have got stuck. And you would have crapped your cop. You would have hit your head on the desk. Things wouldn't have worked out. You would have came out feeling depressed. No time for depression. As a man, you can't be depressed. Yes. What happened? The negative 2. Divide by minus 2. Divide by minus 2. Negative divide by negative is a positive. I wanted to keep this as a 2. So negative 1 will become plus 1. And then plus will become minus. You swap the 2 and you cancel the sign. No, that was in the next step here. Sine squared is equal to that. In my last step, I want sine 11. So I find the square root, and then I find the square root. That I just showed you how I got that. Are you with me? Okay, quiet. Maths is dead. You can't let the dead thing... no, we just answered that question. How should you know you should use cos? Because you will get stuck if you use sine. If you had to use, if you got half an angle, just use cos. You know why? Mr. K, Top K said so. Look here. If you wanted, so you said, okay, how do you know you had to use cos? Why couldn't we use sine? All right, so let's use sine. Sine 11. No, sine 22, sorry. Sine 22. Sine 22, because that's the angle that's given, is equal to m over 1. So sine 2 times, because you want sine 11. So you now so excited in the exam, you think you're right, but you are so wrong. Because you're going to go sine 2 times 11 is equal to m over 1. Then you're going to say 2 sine 11 cos 11 is equal to m over 1. And guess what? You are stuck. Nicely. You got a sine 11, no problem. You got a sine 11, well done. Bravo for you. you are dead. The problem is dead. The problem is dead. After the step, the problem is dead. You are dead. You are stuck. Does it make sense? If it's back, fight back. You, the comments that are coming in, the guys are on fire here, brah. Let's go, let's go, let's go, let's go. Beautiful. Beautiful. All right, let's go. Watch this. What if they gave you, listen to this, listen, now that we're done with this, we're wrapping up. So now they give you this, guys. They give you that. They give you that. Take this one down. Take this one down. This is P, that's Q, that's R, that's S. That line is parallel to that line. That's angle beta. That's H. That is equal to that. That is X. That is alpha. Show that H equals 2x tan beta cos alpha. 6 marks.
Question.
Question, answer. Yes.
What time will we conclude, Mr. Koto?
Ish, it's 2:45. We're going to finish this one up and then we're going to start with our favorite topic, Euclidean. I'll give them about a 5-minute or 7-minute comfort break. We'll push through till 3:30.
Thank you.
We'll push through till 3:30, guys. After this is our last problem. We'll take a 5 or 7-minute bathroom break, comfort break. We'll come back and we're going to Dala, our last topic. The one that's been killing you. I'm going to show you how to knock it the hell out. This is KO. KO. Right, watch. Shh. Pay attention. Let's do it together. How's our comments coming in? How's our guys? Onliners, are they loving us? Or they hating us? Let's go. This is an isosceles triangle. So if that is angle alpha, that is angle alpha. If that is X, that is X. The aim of all these problems, guys, is to rename the common side. So we're going to use angle R as our reference angle. So this is angle R is 180 minus 2 alpha, sum of angles of a triangle. Alpha, alpha, that's an isosceles triangle. So obviously that angle R is equal to 180 minus 2 alpha. Now the fun starts. Now the fun starts. We need to rename the side. We're going to be using the cos rule. I'm using the cos rule. So QS squared is equal to X squared plus X squared minus 2 times the product of the two sides cos of the included angle, 180 minus 2 alpha. There we go. I'm putting a big tick there. On-sighters, bums on seats, eyeballs on screen. Are you guys paying attention? You know what I'm doing? Are you sure? No, she's disconnected. She's DC'd, bruh. She's brain fried already. She's at the point now where she's seeing stars, my bro. She's in Mercury, Venus, Earth. What's the last? She's on Pluto already, bruh. She's seeing about 2,000 stars around her.
Mr. Koto, what's
Yeah.
there for lunch?
It's a biryani, bruh. Yeah, the thing kicked. Right, let's go. We started the cos rule. Let's go. QS squared. Guys, are you following? The cos rule. Are you all following? Are you following? The cos rule. Now let's go. X squared plus X squared is 2X squared minus 2X squared. Cos 180 will become cos 2 alpha. We reduce this. 180 minus is in my second quadrant, cos in my second quadrant is negative. Negative times that negative is a positive. So cos squared, qs squared is equal to, I can take out 2x squared as my highest common factor into 1 plus cos 2 alpha. So qs is equal to the square root of 2x squared into 1 plus 2 cos 2 alpha. So qs, my only perfect square here is x squared, so I take it out. X square root 2 into 1 plus cos 2 alpha. Right, but be careful. In your final answer, there is no double angle. So get rid of the double angle. Qs is equal to x square root 2 into 1 plus. Now comes the question, which of these formulas do I use? Which of those formulas for cos double has got a minus 1? Here's a plus 1. I need one with a minus 1. So 2 cos squared alpha minus 1. 1 minus 1 is 0. Qs is equal to x square root. I'm left with 2 into 2 cos squared alpha. Qs is equal to x square root. 2 times 2 is 4 cos squared alpha. Qs is, this is all a perfect square. Square root of 4 is 2x. Square root of cos squared alpha is cos alpha. So now I don't think I'm right. I know I'm right. 2x cos alpha, 2x cos alpha. We know we are on the right track. We don't think, we know. Onliners, Chalamut pop, Sunny. Zubair Daniels, you're using Mother's Day. Your mother will be proud of you when you bring your 100%. So don't worry. You'll give her the best Mother's Day present at the end of the year. Inshallah, Ameen. Say Ameen. Khalifta Bruce. Right, now we're not yet done. Obviously, we need to get to H, brah. So if that is angle beta, then this is angle beta. We need QS and we need PQ. So that's beta. These two are equal alternate angles. That's my opposite side. That's my adjacent. So what? Tan beta. Tan beta is equal to my opposite over adjacent. So is equal to H over QS. That's opposite over adjacent. I want H on its own. I want H on its own times QS times QS. H is equal to QS tan beta. But is QS called QS? No, what is QS called? And here's your final answer coming up. Therefore, H is equal to, instead of QS, 2x tan beta cos alpha. Game over. You got yourself 6 marks, brah. Say shukran, Khalifta Bruce. Sheikh Kota say, Sheikh Kay, Sheikh Kay, met die tajweed. Kota. This is the time where we lose it, bruh. Where we start losing it. When you are doing 2 days, crazy math. Bruh. Today, you guys going to be taking a walk at the waterfront or going home. You're going to be counting bricks at home, bro. Let's go. All right, let's go for break. You guys want to take a small break, bathroom break? What's the time? It's 1:45. I'll give you guys 7 minutes. 7 minutes comfort break, 7 minutes bathroom break. We come back and we end up with my favorite topic. Go for break. Son up. I'll see you guys in 7 minutes. See you onliners, 7 minutes, and we end up with Euclidean. Assalamu alaikum. is my face there. It's my big head there. Welcome back, welcome back, welcome back. Let's see the comments that are coming in. Hope you guys enjoyed your comfort break. We're going into similarity and proportionality. Put the heading Euclidean. I'm going to show you the technique of doing this Euclidean. I'm only doing the grade 12. I'm not doing the grade 11 circle theorems. That you can do as revision with your teachers at school. I'm only doing proportionality, and similarity. Right. Number one, you got to know the proof. So please, that's bookwork. I'm not doing it here with you. I'm not doing that with you. Here we go, here we go, here we go. I'm not doing that with you. Okay. When do we need to know proportionality? Pay attention. Proportionality. Proportionality is when you have a single triangle and you've got parallel lines. So P for proportion, P for parallel lines. That will help you to remember when to use proportionality. Right. So whenever you have, so therefore I can tell you F, G, H, I, J. So if I told you that this is X, that is 10, that is 15, that is 30. Solve for X. This is proportionality. This is not similarity. So in fact, you can immediately say FG over FH is equal to FJ over FI. Proportionality. You don't need to say in triangle FGH and triangle FHI. You don't need to prove similarity. Because you got parallel lines, you can immediately use prop theorem as a reason. That's it. So FG is X over FH is X plus 10 is equal to Fj, which is 15, over Fi, which is 45. Cross multiply and solve for x. 45x is equal to 15 into x plus 10. 45x is equal to 15x plus 150. 45 minus 15 is how much? 30x is equal to 150. X is equal to 150 divided by 30 is 5. There we go. X is equal to 5. And that's proportionality. If you want to say x over 10 is equal to 15 over 30, no problem. Then you cross multiply. You're now going to get 30x is equal to 150, x is equal to 5. You can also say, in your proportionality, you can say that over that is equal to that over that. As long as you have, remember, you must have unknown over known is equal to known over known and solve for the unknown. You can only have one unknown in a proportion. Right, Kiam? Right, here goes. Now let's give you another one. Let's give you another proportionality to get you busy. Then we're going to move on to similarity. How's our onliners doing there? How's our comments coming through there? How are we doing there, guys? Are we still there? Wish these workshops was not ending today. Thank you, TTO Kicks, wherever you're from. Here goes. Here goes. Here's one from a past paper. Here's one from a past paper. Take this one down, guys. Take this one down. So they give you a line coming down here, and they give you a line coming down there, and they give you a line going across there. Right. They tell you that that line is parallel to that line, and they tell you that that line is parallel to that line. PQ. This is P, that is Q, that is S, that is T, that is R. That's 22 centimeters. This is V, that's 24 centimeters. This is 12 centimeters, and that's point T. Right, in the, let's see, calculate QR. Find the length of QR. Find the length of QR for 5 marks. That's it. Find QR. Basically, they want this entire length here. They want the entire QR length. So this is an exam question. Again, this is not similarity because it's got parallel lines. P for parallel, P for proportion. So watch here. You got a big triangle there, you got a small triangle here, and you got another triangle there. Let's first find TR. So what I'm going to do, let's do that. I'm going to highlight the triangle I'm working with. And we've got a pair of parallel lines there. These two lines are parallel, and I'm highlighting that. So now I'm going in triangle, PSR, PSR. I'm not proving similarity. I'm now going TR over TS is equal to VR over PV. Prop theorem, proportionality theorem. So TR over TS is equal to VR over PV. So TR is equal to 22 times 12 over 24. So TR is equal to 22 times 20. Where's my calculator? Huh? Can't be, man. 22 times 12 divided by 24. 22 times 12 divided by 24, I get 11. 11 centimeters. So that means now we just found that out to be 11 centimeters. Are we all okay with that, guys? Right. We needed this entire line, so I need QS. Now I'm going into the big triangle. Watch here. Now I'm going into the big triangle. I'm going into that triangle there. That, and that. And I'm using these two parallel lines. So now I know that this side, QS, because I need QS. So now I write in triangle, PQR now. QS over SR is equal to, so QS over SR is equal to PV over VR. So I want QS over SR is 12 plus 11 is how much? 23 is equal to PV. PV is 24 over VR is 22. So QS is equal to 24 times 23 over 22. Take my big head out of the corner there. 24 times 23 divided by 22. 25,09. Let's go again. 24 times 23 divided by 22. 25,09. 25,09. So this is 25,09. Therefore, they want, what did the question want? QR. QR is equal to 25,09 plus 12. So it's that plus 12 plus 11. (48,09) units. And there we go. That's our final answer. And that's proportionality. That is proportionality. Now let's do similarity. Let's now do similarity. I'm going to do two problems on similarity. So we did two problems on proportionality, two problems now on similarity, but I'm going to include a little bit of grade 11 work in here, and that's going to take us to the end of today. That's it. That's all you need to know, how to play with similarity and proportionality. Again, I hope this weekend has put everything for you guys into perspective. Any of you would like to follow our channel, guys, you can follow my channel. You can Google me, Mohammed Kota, Kway Institute. You guys can get hold of me, and we can activate you. We can work with you. Remember, Mohammed Kota, my name. You can Google me. I'm a lot. Even on YouTube, you can go under Mohammed Kota. Let me just clear that. You know what, guys? At 4:30 today is my cooking show. I'm also a chef. Channel 347. I'm serious. I'm not even joking. I'm going. It's going to be aired today at half. Let me see what time. Just give me let me just double check what time. Give me a second. Sunday, 4:30. You can go on channel 347 DSTV. Channel 347 DSTV. Today is at 4:30 p.m. Yo, you don't want to miss today's chow, bruh. 4:30 p.m. Or you can just go, you can live stream it on Hilal from your phones. You can just go to hilal.tv and you can live stream. No, not live. I recorded it on Wednesday before I came. So, but today it's going to be aired. The show is going to be aired. The show is going to be aired. It's called the Havat Show. So you guys can even go on to YouTube and check. Havat in Indian means delicious. So Havat Show. So there we go. You guys can just take that down. Maybe just FYI. Yeah, so it's a cooking show. Just to get you all busy in the kitchen and get you, so you know what's going on. What's that? Huh?
That's you.
The cooking show. Yeah, you went onto YouTube on my other show. But that's not live. Those are my previous shows. Yes. Huh? Yeah. What a winner. Right, let's go. Yeah, question, Kiam? I'm trying to think. What was it? Shakshuka. Ever heard of shakshuka? It's a it's a breakfast. It's a Middle Eastern breakfast. It's with egg, and it's amazing. You have to watch today's show, man. When you guys go home, promise me you're going to watch it. It's live. I'm also going to be watching it. I think I'll be on my way to the airport and I'll be checking myself. I want to see if I made any flops. I didn't. It was a quiet show. Anyway, see you guys at 4:30 on the show. Anyway, let's get back to math. Right, here we go. So take this one down, guys. Take this one down. So you have a tangent going this way. You got a line going from there up there. You got a line coming down there. You got a line going across there. You got a line going across there. You got a line coming across there. And you got a line coming right across there. And I missed it by so little. There we go. There we go. There we go. There. I fixed it. I fixed it. I fixed it. I fixed it. Must have fixed it. We improvise here, Baba. We improvise. There we go. Here we go. Here we go. GF. GF. That line is parallel to what? BA is a tangent and FG is parallel to EA. Oh, that's E on the top. That line there is parallel to that line there. Here we go. That's A. Let's call this E1, E2, G1, G2, F1, F2, C1, C2, C3, C4, D1, D2. Right. Proof. Let's go. Proof. This is exam. Right. How's the comments coming in there? Are we all right there with my Owens? ABC, prove that triangle ABC is similar to triangle ADB. Number 2, that AB squared is equal to AD times DC. Number 3, that triangle ACE is similar to triangle AED. And the last one, that AB equals AE. Here we go, here we go, here we go. How's our time? Quarter past. Yeah, we're going to do this one. We can probably do one more. And then I promise you by 3:30 we should be done. With, Sheikh with everything. My two passions, food and math. Let's go. Right. Now, they're asking you to prove two triangles similar. We're working with separate triangles. So whenever you're working with two separate triangles, we said P for parallel, P for proportion, S for separate, S for similar. So now we got to prove. So let's go. In triangle ABC and triangle ADB. Right. Where's ABC? ABC, ADB. So what you do, guys, what you do, split the two triangles up. S for similar, S for separate, S for split up. So let's split the two triangles, triangle ABC and triangle ADB. So let's go. ADB. That's A, B, C. That's C2. You can call that B1, B2 also. And that's B2. That's A. That's D1. This is B1 and 2. That's that whole angle. That's the whole angle B1 and B2. So now we go in triangle A. So angle A is equal to angle A. So X is equal to X. Angle A is equal to angle A. Common angle. We need one more angle. The third angle will automatically be the same due to sum of angles of a triangle. Which other angle is equal, guys? Which other angle is equal? We know that B2 is equal to D1, tan chord. This is a tangent. Angle B2 here, angle B2. So I'm going to put a tick. Angle B2 is equal to angle D1. Angle D1, there we go. Angle B2 is equal to D1. So angle B2 is equal to angle D1 from the original tan chord theorem. So the last angle that's the same is which angle? From this triangle, C2 is equal to DBA, or B1 plus B2, DBA. And that is your remaining angle. Therefore, triangle ABC is similar to triangle ABC. ABC. So you can put a dot and a dot. ABC. Cross tick dot. Cross tick dot is similar to triangle cross tick dot. Where's the cross here? A. Where's the tick? D. Where's the dot? B. There we go. I use this method of cross tick dot. Always works. So it's easy to pick up which angles are equal. So there we go, we're done. Onliners, how are we doing? How's my brasa? Are they quiet?
It's going bananas.
It's going bananas. Right, let's do number 2. So we're done with number 1. Let's do number 2. Maybe we can just wrap up with this one, because if you can use the same, if you understand this concept, you can understand all the concept. Just remember, P for proportion, S for similar, and separate the triangles. Let's go into number 2, AB squared. Now we've got triangle ABC. I'm just going to do this again. ABC, cross tick dot. Cross tick dot. Right, let's answer question number 2. Let's answer question number 2. Guys, I think we're going to finish up here because I don't want to go a second after 3:30. People will be screaming and swearing me. But alhamdulillah, we've covered a lot. Number 2. Right, AB squared, ADDC. So AB DC, AB squared. So we know that AB, wait, let me just see. AB squared, oh sorry, it's AB. What the hell did I do? AB squared is equal to AD times AC. Sorry, AD times AC. My mistake, your fault. I never take the blame. Never, not me. Never. People can catch me red-handed. I say, wasn't me. Right, AB squared. So we got AB over. So we got AB over AD. Remember, cross to tick. Cross to tick. Cross to tick. So there we go. AB over AD is equal to, now I need AB squared. So I need AB at the bottom here again. Right. I need AB here at the bottom again. So it's cross, so it's the first and the last. So cross dot, first and last, AC. So what was that? Cross dot. Cross multiply, AB squared is equal to AD times AC. So we answered that one, we answered that one. The next two, triangle ACE, triangle AED. Ah, nice one. Start with that. We're almost at the end, guys. It's 24 minutes. We got 6 minutes before the end of the full weekend. We family now. When you spend the weekend with Kway, we become family. And inshallah, family, online and on-siters, I hope to see you guys. I wish you guys all the best. Lots of love from Kway and Awqaf. Hassanain loves you. I promise you he does. And we hope that you're all going to crack this paper, and we hope to see you guys again at SP. SP will be the one before prelim exams. And yeah, like I said, follow my channel, connect with me. I'm not allowed to advertise my phone number here, but you'll get just search a little bit for me, you'll get my phone number. And I promise you guys can follow my channel, and I've got a whole lot of other programs as well as part of Kway. So if you guys want to be part of the Kway family, just Google me and get a hold of me. I promise you, you can text me, you can WhatsApp me. My phone number is on the internet. My phone number is on the site. Small Google search, you'll find me. Send me a WhatsApp, send me a text if you guys enjoyed today's show. And I promise you, I'll keep you informed and we will mentor you right through until the end. Right, let's do number 3. Let's do number 3. In triangle ACE. So now, in triangle ACE and triangle AED. Guys, you guys can get, oh yes, you can get me on Facebook also. You can send me on Facebook, Mohammed Kota. And you'll see under KWay Institute, Mohammed Kota. And you will see I've got it's a puzzle piece as my logo. So connect with me on Facebook as well. Or you can follow KWay Institute on my Instagram, IG. For the gram, baby, for the gram. I'd love to connect with all of you. Doesn't matter where you guys from. And let's get started. Right, in triangle ACE and triangle AED. Okay, let's do. What's the first thing we do? We split, Baba, we split. Triangle AEC or ACE. That's C1, that's E2. And triangle AED, the big triangle. Guys, you have to do this. Honestly, you must do this in your exam. Do it in pencil or do it in a different color. This whole angle is E1, E2, and that angle is D2. D2. Right, let's go. Which angles are equal? Clearly, we can see angle A equals angle A. Angle A equals angle A. It's your common angle. Number 2. Right, which angle is equal to which angle? Don't look at this. We know that that angle is equal to that angle. Don't look here. Here we are only putting when we find the angles. We look at the original diagram. Right, let me help you out. Angle E2 is equal to angle F1, alternate angles. These two lines are parallel. And angle F1 is equal to angle D2. Exterior angle of a cyclic quad is equal to interior opposite. So we're using grade 11 circle. So angle E2 is equal to angle F1, alternate angles. But angle F1 is equal to angle D2. Exterior angle of a cyclic quad. Exterior angle of cyclic quad. So therefore, angle E2 is equal to D2. So angle E2 is equal to angle D2. And then obviously, that becomes your remaining angle. Angle C1 is equal to angle E1. And then the third one is angle C1 is equal to angle E1 plus E2, angle E. That's your remaining angle. Therefore, triangle ACE is similar to triangle. So ACE, dot cross stick, angle, triangle AED. Here we go, we are done. So you got 3, 6, 9, and 5, or 4. 9 and 4, 13 marks. 3 marks, 3 marks, 3 marks, and 4 marks. Prove that AB equals AE. Prove that AB equals AE. All right, now let's look at this. Right, let's answer the last question. I hope you took all this one down. You took this down. AB equals AE. Okay. So to answer this question here, we know that AB squared is equal to AD times AC from question number 2. But we also know that from ACE is similar to triangle AED. So we need a AE. I got a AB, I got a AB. I need a AE. So AE over AD, there we go, over AD is equal to, I need AE at the bottom, the first two, AE. So what would be the first two here? AC. Therefore, if I cross multiplied, AE squared is equal to AD times AC. Wow, what do I pick up? I got AD times AC. I got AD times AC. Therefore, equation 2, equation number 1. So therefore, AB squared is equal to AE squared. So find the square root. Therefore, AB is equal to AE. And there we go. There's your last 4 marks. Boys and girls, ladies and gentlemen, dames and heren, apples and peren, we are now done. Officially done. Guys, I think you guys all deserve a nice round of applause. Well done. Well done. With all our trajectories, with everything. We went into orbit. We got lost in space. We had some glitches. The capsule disappeared. We came back. We landed safely. We are officially done. Let's see our comments from our onliners. Well done, well done, well done. Don't just log off yet, guys. Like I said, just a thank you. I'd like to thank everybody. I'd like to thank all of you for all being part of this program. I'd like to thank Awqaf for making this program possible. I'd like to thank the Department of Education for making this possible. And I just thought that I'll leave you guys with this. Last and not least, just give me a second. Right, I'm just doing the final thanks. And last but not least,
I want to thank me. I want to thank me for believing in me. I want to thank me for doing all this hard work. I want to thank me for having no days off. I want to thank me for never quit. I want to thank me for always being a giver and trying to give more than I receive. I want to thank me for trying to do more right than wrong.
Last but not least, I'd like to thank me. Me for all the hard work, me for coming from Cape Town, and me for loving you guys and making sure that you guys pass. Inshallah, I hope to guys see you guys in June and at the end of the year, inshallah. Guys, I hope you guys enjoyed. It was a fantastic program. Thank you all, thank you all, thank you all. Assalamu alaikum and good afternoon.
And that's it. We come to the end of the program here, inshallah. Awqaf's SA Maths workshop for grade 12, Sunday, the 12th of May. We say shukran so much.
Oh, yes, and a happy Mother's Day to everybody.
And see you next time. So, all of those, inshallah, would like to get whatsoever we learn during the weekend. They can join us online at Awqaf SA, either on YouTube, X, or Facebook. See you, inshallah.
Yeah, I needed that big mic.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice.
Woo, we are
and
done, Baba.
celebrate.
A whole weekend.
Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care.